Hey everybody, Mr. Regan here. And now that we've really explored our thorn palm populations, both from a histogram perspective and making observations in our simulation, we are now going to look at making a prediction that is going to explore how you guys can manipulate our simulator, its environment, to really show that you understand how populations change over time. So we're going to be going through how to use our modeling tool to make a prediction about our thorn palm population over a course of 50 generations. And we're going to look at completing this modeling tool that focuses on a specific goal that you're going to have to accomplish. Now, before we get into the modeling tool, a couple things to keep in mind. When you go into the simulator here in a little bit, you're obviously going to be in the water storage mission here in the far side. And if you notice at the very start, you have the ability to manipulate how much rainfall there is, whether it's low, whether it's medium, whether it's high. So you obviously can't change really anything, and we don't want you to change anything about our thorn palm population because this is the starting distribution we had from all of our previous tasks. So you're going to be keeping the population the same, but you're going to be changing the rainfall here to help accomplish your goal, and we're going to be making a prediction as well that accomplishes the following goal. So below, if you notice, we have our model. We have our starting population that you just saw, and then we are going to make a prediction in here, and we're going to be dragging and dropping different features across our model to accomplish this goal. So you need to create a model that predicts how and why traits for increased levels of water storage can become more common in a thorn palm population over 50 generations. So that's a big goal here, and there's a lot going on. So first and foremost, your model is going to be a prediction. As you drag and drop things into our different modeling sections here, you're creating a prediction. So how you drag and drop these will show me what your prediction is. Now you're going to predict how and why traits for increased levels of water storage. So taking a look at our starting population, think to yourself, which variations in here represent those levels of water storage, okay? Because you're going to need to show how and why traits for increased levels of water storage become more common, okay, over time. So we need the increased levels to become more common. So think to yourself, what environment would make these traits adaptive? In order for these traits to continue existing in our population over time, they need to be adaptive for a specific environment, okay? Now, when we do this, we need to obviously have that set of traits found in our population after 50 generations. So ask yourself, what would my distribution of those traits look like after 50 generations? So to start, we're actually going to come down here to the very bottom and think to ourselves, what kind of environment, okay, would lead to increased levels of water storage becoming more common? So down here it says environment changing from blank rainfall to blank rainfall. Your job is to drag and drop either low, medium, or high to kind of fill in those blanks, thinking about what did the environment start as, okay, before changing, and then obviously changing our population and the traits found there. So you're going to drag and drop whatever you think. If it's low and medium, okay, you can do those two. You can do high and medium, whatever you think it is, but you're going to drag and drop those features, okay, into these sections to complete the sentence for the first part, okay? Once you have that, you're then going to have to think about what would the environment need to be in our future to get those increased levels of water storage, okay? Again, you're going to drag and drop whatever it is. Do you think it's low? Okay. Do you think it's medium? Okay. Or do you think it's high? When you're done, your prediction will have these descriptions, okay, these environment descriptions, okay, for what it looked like at the beginning and then what it looked like afterwards. Now, the second part we're going to need once we finish our environment is the adaptive, non-adaptive trait icons. So after we drag and drop our environment descriptions here, we're going to need to indicate which of these traits are adaptive by putting a plus above them, wherever those traits may be, okay? And then obviously we're going to also need to move the minuses to show what traits are not as adaptive or are probably not going to show up after those 50 generations. Okay. Once we put our pluses and minuses in our starting population, we're then going to obviously make our prediction. So we're going to include our histogram data prediction, which are our bars here, okay, which is going to help us understand what should our distribution look like after 50 generations. Remember, you drag and drop wherever you want to show what that distribution would look like, and then you take your little boxes here and you can shrink or hire them based on whatever you think that distribution of traits would look like. Okay. So when you're done, we'll see a couple different things in your prediction. We're going to see, number one, your non-adaptive and adaptive trait icons in your starting population. Which ones are your adaptive? Which ones are your non-adaptive? We're going to see your environment description. So what did the environment start as? What did it end as? And then we're going to see your histogram data predictions. What your distribution of those traits look like after 50 generations. Remember, whatever you predict should accomplish your goal. So we've thrown a lot at you. Okay, we've looked at the goal, looked at how to drag and drop the modeling features, and we looked at how to drag them and drop them to accomplish that goal. If you have questions, reach out to me. Otherwise, good luck.